Good morning, my name is Bergida, and I've been working with Group 12 and my other fellow analysts, Scott and Cameron, to determine a regression model to analyze home prices in Mandeville, Louisiana. As you can see here on a map, this is where Mandeville is located in Louisiana, if you did not know. So our goal was to develop the best regression model to predict home prices in this town. So through analyzing the relationship between home price, quantitative data, and categorical variables, we were able to take a stepwise regression of models and then determine the best. We compared adjusted R-squared values to see which one had the highest relative value. We removed predictor variables that have the least significance through forward selection, backwards elimination, and a model of backwards elimination with the probability of 0.15. We also aimed to minimize the sum of squared residuals so that we would get the best model possible. Next up, I'd like to discuss our data set. So we collected data from 100 randomly selected homes on Realtor.com. Over to the right, we have some summary statistics on the data we collected. Some examples of the quantitative data we collected include latitude and longitude, home price, the square foot of the home, the lot size in square foot, the number of bedrooms plus the number of bathrooms, and then year built. Additionally, we have some categorical variables or indicator variables. So if a home had a fireplace, we listed 1. If it did not have a fireplace, 0. And the same thing for garage to create our data set. A limitation of this data set is that all of it came from Realtor.com, except for the latitude and longitude data, which was obtained from latlong.net. So next up, we had to form our training and test set. So our training set was 80% of our entire data set. So it was the first 80 observations or our first 80 rows of house data. Our test set was 20% of the remaining data set, so the remaining 20 houses. Over here to the right, you can see a pie chart that breaks down the proportions. I'd like to discuss more limitations of our data set. So all of our home data was obtained from Realtor.com. Other websites might have different data, so our data set might be a little skewed. Also, the definition of a garage. Is it detached or attached to the home? How many cars does it accommodate? We don't know. Also, fireplace. How many fireplaces are in the home? We can't quantify this. Also, our data set was relatively small. With only 100 observations, we didn't have the resources available to collect more. And there are some outliers in our data set, which you will see later in the maps.
Hi, I'm Cameron, and I'm going to talk to you about the trends of housing prices we can test on the map. So as you can see, these lines represent the trends of housing prices in Mandeville, Louisiana. The orange line here depicts the most expensive homes, and the blue line here depicts the least expensive homes that we collected. You can see that we have a few outliers that would affect these linear trends. So one being this green dot up here. That's a housing price that's quite north compared to the rest of the data, and that would skew that green line up. In addition, there's also this red dot here that would skew this red line of housing prices down over here. So just the data that was collected farther away from the rest of the houses would kind of affect the trends of these lines. This is a contour map of the housing prices. So again, these orange blots depict the neighborhoods with the more expensive houses, and then we can see the blue dots or the blue contour over here would depict the least expensive houses. So as we go farther west, we see more expensive homes, and then as we go east, we kind of see lesser expensive houses. In addition, this is the lot size. The larger square foot of houses tend to be west, and the smaller square foot homes tend to fall east. With a couple of outliers, you can see a little bit of blue over here and over here as well, with lighter shades of contouring over here. That depicts kind of the data that wasn't really clustered together with the rest of the housing prices.
Hi, I'm Scott. I will introduce how we can get the best model by the 3 methods. So at the first, we will use the forward selection for the training set. We're starting with the 0 predictors, and according to the lowest probability, we added the square feet as the first predictor. And the second one, we added the year build and the number of bathroom plus the bedrooms. The last is the garage. And second one, we use the backward elimination for the training set. We started with all predictors, and according to the highest probability, we removed the fireplace, added the first, and the lot size, and the garage, so that we can get the second model. And the third one is also the backward elimination for the training set, but we changed the probability value from 0.1 to the 0.15. And so we can remove the highest probability of fireplace, and the second is lot size. So we can get the third model that's the same as the first one.
So this is where we did our cross validation by the test sets. So forward selection and then the backward selection with the probability of equal to 0.15 had the same variables and the same adjusted R-squared values. So we only did 2 cross validation sets. So we did the cross validation set with the variables we collected from those 2, as well as the variables collected from the regular backwards elimination. So in this one, we have just the year built, the square feet, and the number of beds and baths. But in this test, we have the square footage, year built, the number of beds and baths, plus the garage. So now we compared the adjusted R-squared values, and we could see that the ones with just year built, square footage, and the numbers of beds and baths had a higher adjusted R-squared than the one that included garage. So that's why we chose the one without the garage. So this is where we go to the best model. We then considered all 100 variables when coming up with the different predictor values to put into our final y-hat model. So we considered the square feet, year built, and the numbers of beds and baths. So this is just the analysis of variance and the parameter estimates for these variables and for our final model. So to check the appropriate assumptions, the linearity condition is met because there shows that there is a nearly linear relationship, as well as the independence assumption because all of the variables were independently chosen from Realtor.com. The equal spread condition is met because it doesn't show a funnel shape, and the nearly normal condition is met because the sample size is larger than 30. So some problems we do have, because you can see that there are some outliers in the residual plot. As the prices actually increase above 1 million, you start to see more outliers. This is just because of those 100 homes that were collected. Less were in the $1 million range than below the $1 million range. So if we had a larger sample size that really showed all the homes in Manville, Louisiana, this value would change. So that finally brings us to our conclusion.
So in conclusion, our group determined that the best model uses the predictor variables of square foot, year built, and number of bedrooms plus number of bathrooms. All in all, this develops a model that will give you a quite accurate home price. However, there's some outliers and that will skew your result. Thank you guys for your time today, and please purchase our model.